Hi, my name is Ali, and I'm going to try explaining what it means to fail to reject the null hypothesis. But before I can do that, I want to give a little bit background to what the null hypothesis actually means. So let's say you're having a hypothesis test and you want to try a independent factor or a treatment on the sample to see if that treatment or independent variable has some effect. So you do the test and you come out with the result that the treatment really didn't have a significant outcome. It didn't really significantly change what happened with the effect. It's basically almost the same as if it didn't have it. So your treatment basically doesn't have significant effect, so you have to reject your H1, and then you would have to fail to reject your HO. We say fail to reject HO because there isn't enough evidence to prove that HO is true. An example I want to give is, let's say you were ordering something online. You want to order something online, like a pair of headphones or something. You go and check and you can't find it online. So in that scenario, your H1 would be finding the headphones online, and your HO is not finding it. It's a rough example. It's not one-to-one exactly correct, but it's the best I can do right now. Since you can't find the headphones, that means you have to reject your H1. So now we say, but now here's the thing. Just because you couldn't find the headphones online, the ones you wanted, doesn't mean they're not actually there. You just maybe didn't type in the right words to actually find it, or you just didn't look hard enough. So that's why we say fail to reject HO, because there's not enough evidence to prove that HO is actually correct. You just didn't have enough evidence to prove it wrong. Hopefully that was a good explanation, and the next person will do their section of the video.
There are two types of hypothesis. The first one I'll be explaining is the null hypothesis. This one states that there is no significant difference between specified populations. For example, if there's no change within the data collected, then it will be considered a null hypothesis, or also known as HO. The other type of hypothesis is alternative hypothesis, which means that a change did occur and can be written as H1. An alpha refers to the likelihood that the true population parameter lies outside the confidence interval, and the critical region explains the sampling distribution of a statistic within that region. Now Abigail will be talking about what it means to accept the null hypothesis in certain situations, or to accept the alternative hypothesis.
Hello, I am Abigail, and I'm going to be explaining what it means to accept, reject, or fail to reject the null hypothesis and/or an alternative hypothesis through a fun example. A crazy scientist believes he has created a magical berry that helps you have amazing memory. So let's say if a normal sample mean score would be 20 with the no berry treatment, then after the berry, he thinks it will increase a memory score, meaning it would increase the score of 20, be bigger than 20. As explained by Shazia, a hypothesis testing problem like this one involves a null, alternative, alpha value, and a critical region. Usually, the alpha chosen for many tests like these is an alpha of 0.05. When you have an alpha of 0.05, the bell curve is divided into 95% and 5%. These two regions are composed of the 5%. That's why they're 2.5 and 2.5. These regions are called the critical region, which are which if you have a z-score that lands in a critical region, it means it is an extreme score and not a normal score, close to the mu. The associated z-scores with an alpha of 0.5 is 1.96 or negative 1.96. To test an experiment like this one and see the effects of the berry, you have to make a null hypothesis and an alternative hypothesis. The null hypothesis in this problem would be that the mu would be less than or equal to 20, meaning no effect or worse or opposite effect. The alternative hypothesis would be what the scientist kind of wants to prove or hopes to get, which is a mu bigger than 20, meaning the treatment had an effect and increased the memory ability of the subjects. There are two possible outcomes that you can get while using a test like this one. You can get a z-score that allows you to accept the alternative hypothesis and therefore reject the null. The second possible situation would be you can get a z-score that allows you to fail to reject HO because you can't accept HO and therefore reject the alternative hypothesis. You accept the alternative hypothesis and you reject the null when your z-score is bigger than 1.96 or smaller than negative 1.96. So if you're in the critical regions that I showed before. The second scenario happens when you get a z-score that is smaller than 1.96 and bigger than negative 1.96, which will have your z-score be in the middle. So what does it mean when you accept, reject, or fail to reject the null and/or the alternative hypothesis? In the first scenario, it means that you found significant evidence that the berry made by the scientist has a difference and increased the memory of the subjects. In the second scenario, it means that you did not find significant evidence that the berry increased the memory ability, found evidence that treatment probably has no effect. Thank you, and I hope this example helps you understand what it means to accept, reject, fail to reject the null and/or the alternative hypothesis.
So what happens when we falsely accept H1? When we falsely accept H1, we say that there is an effect when in reality there is no effect. In order to decrease the chance of this happening, we have to make the alpha smaller. So there are type 1 and type 2 errors. First, we'll talk about a type 1 error. And this is when you reject a null hypothesis, even though it is true. Here in the example, the null hypothesis is that you are not pregnant. The doctor tells you that you are pregnant. But in this case scenario, the person is actually a man, and he is not actually pregnant. Thus, it will be a false positive and a type 1 error. And there is also a type 2 error, where you fail to reject the null hypothesis, but it was true. An example would be the same as last time, but the null hypothesis is that you're not pregnant. In this case, she's telling her that she is not pregnant, but in actuality, she is pregnant. This will be a false negative, and thus a type 2 error.